Hello and welcome. This is Cambridge O-Level Chemistry paper number 2. The subject code is 5070. This is May-June 2021 exam, and this is version of 2 for this exam. This is 1 hour and 30 minutes exam. So let's start. Section A. It says, answer all the questions in this section in the spaces provided. The total marks for this section is 45. Question number 1. Choose from the following compounds to answer the questions. So here what we see that there are A, B, C, D, E, F, G, H. So 8 different compounds are given to us. So from general inspection, we can see that some of them are alcohol, some of them are double bond compounds, some of them are acids, and some other form of hydrocarbons are given. So let's see what sort of questions they are asking from us. So, so it says each compound may be used once, more than once, or not at all. So we are pretty good if we are going to use, or we have the option to use multiple of them for each answers. So part A, state which compound has 11 molecules, in sorry, state which compound has a molecule with only 11 atoms. So we just have to count the total number of atoms. So for example, in this A, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a total of 9 atoms here. So in B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 in B. In C, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is a double bond, so we call it 11. Then we have here 1, 2, 3, 4, 7, 10, 30, 14, 15. So we have 15. So we have to find molecule with 11 atoms. So part C is the answer with us. So we can just simply say. Then it says question number A, part 2. State which compound is oxidized to form ethanoic acid. So remember, uh, oxidation of alcohols, when oxidized, they form acids, or you can say hydrocarbons or alcohols. When oxidized, they form uh, acids. So for ethanoic acid, we need to find, and first of all, an alcohol. So if we see from this picture, how many alcohols we have. So we have F is an acid, C is an acid. So alcohols will have OH bond in the end, or OH. So we have to find something that has OH. So OH, so we have OH here. So yes, this comes in something like that, but it also have an H2N. So generally we are talking about only carbon, hydrogen, and some OH. So this is not good. So this looks good for an alcohol, sir. And again, so this is CH3, also C2H5OH. So this is ethanol, and when this is oxidized, so it becomes H3COOH, and that will be your acid or ethanoic acid. And eventually we can say that A is the right choice we have. Next part, state which compound is an isomer of butene. So remember, isomers are compounds having same number of atoms. Same isomers, same number of atoms. So if for butene, so butene will have C4H8. The formula for butene is this. So so the compound will have only carbon and hydrogen, and it will have total number of 12 atoms. Okay, so let's see which compound. So we have calculated this till part A, B, C, D. So none of them have 12 compounds. So let's see part E. 1, 2, 3, 4. So C is 4. 1, 3, 4, and H 4, 4, 3, 7, 1, 7, 8, 9, 10. So C4H10. So no, this is not. Again, this comes with OH. So this is not an isomer of butene. Uh, then we have this again, COH. It's not, again, it comes with O. So let's try this one. This one had 12. Oh, so yes. So we need to have 12 ones. So 1, 2, 3, 4, C4, and H2, 2, 2, 2, H8. So this is C4H8. So part B will be the right choice we have. Then part 4, it says compound that reacts with hydrogen in the presence of a catalyst to make an alkane. So remember, uh, this is catalytic hydrogenation reaction uh, of alkenes. So alkenes, for example, any alkene plus hydrogen plus catalyst will give you alkene. Okay, so we have to find out an alkene. Um, so if we see this part D, alkenes will have double bond in them. So this looks like a good alkene. It must not have OH or COH. Not no O, no O. This do not have double bond. This again is an OH. This do not have a double bond. This is not the case we need. Again, this is part BD will be the or it's an alkene, and this will be the best choice we have. So C 1, 2, 3, 4, 5. So this is C5, H3, 3, 6, 7, 8, 9, and 10. C5, H10. So this is completely an alkene. So the answer D is the best choice we have. Then it says contains 4 different elements chemically combined. So 4 different. So we are finding elements C, O, H, and we need to find a compound which have one another one. So let's see. So we can see that the only this compound H have N inside it. So we can just simply say H is the only other compound that contains 4 elements that are chemically combined. So this is the right answer for this question. Okay, moving ahead, it says identify 2 compounds that have pH of less than 7 in an aqueous solution. So remember, acids have pH less than 7. So acids will have COOH at the end. So we have this COOH, we have this COOH. So this is not an acid. COOH is replaced by this. So this is something else. This is again not an acid. This is not. So we have only compound F and H as acids, and we can just simply, oh, sorry, C and F, not C, compound C and F are the acids we have. So this will be the answer for this. Okay. So moving ahead, question number 2, it says oxygen, sulfur, selenium, trillium, and polonium are in group 6. State the percentage composition of volume of air or volume of oxygen in dry air. So remember, volume of oxygen in dry air is somewhere around 21%. So that would be a good answer. Again, state one large scale use for oxygen. Well, oxygen is used many cases. So it is, you can say, um, breathing, uh, uh, purposes in hospitals. Also, it's also used as in welding. Uh, it's also used in steel manufacturing. Steel manufacturing. It is also used in fuel cells. So there are many uses of oxygen. So again, a good one is welding for me, or fuel cells, or in hospital. I mean, you can use any one of these for your answers. Then part C, it says two isotopes of polonium are shown. Explain why both isotopes have the same chemical properties. So remember, chemical properties are primarily dependent on the number of electrons in the valence shell. So both of these isotopes will have same number of electrons in their valence shell. So just simply write uh, both of these isotopes have same electronic configuration, that is valence shells having same number of electrons. Okay, so that is good. So remember, isotope, same number of electrons but different number of neutrons is the definition. So again, give one difference in the atomic structure of these isotopes. So it is same number of uh, uh, protons with different number of neutrons. So we can say different number of, so let me say, neutrons. So right, same different number of neutrons. So polonium 20984 has 125 neutrons, and whereas polonium 20884 has 126 neutron. Sorry, 108, not 110, 10 and 126 neutrons. So remember, number of neutrons for this. So 1 to 10 minus 84 will give you 126. This is neutrons. Um, Again, this is 209 minus 84. This will give you 125. This is, so they both have different number of neutrons. They also both have different number of uh, same number of protons but different number of neutrons. So uh, this 210 is neutron plus protons. So both will have same number of protons, 84 and 84. Okay, so this is how, or just simply use the definition of isotopes. Isotopes have same number of neutrons but same number of protons but different number of neutrons. Uh, Moving ahead, part D, it says selenium forms a compound that contains only selenium, oxygen, and chlorine. The compound contains 9.6% oxygen by mass, 42.8% of chlorine by mass. Calculate the empirical formula for this compound. So we have selenium. Again, we have chlorine, and we have oxygen. So if we see, we can see that the oxygen is 9.6% by mass, chlorine is 42.8% by mass, and selenium is, so we just simply add 42.8 to 9.6 and subtract it from 100. 100 minus these two, it comes out to be something around 47.6. Okay, so we have 47.6% of mass of selenium. 0.8 plus 9.6, yes, it's 46.8. So then these are the percentages. Then the second step is divide by molecular mass. So molecular mass, so divide the same by the molecular mass. So with selenium, remember, selenium molecular mass is 79, chlorine is 35.5. and oxygen is 16. So selenium, if I am here, I'll be dividing 47.6 divided by 79. Then with chlorine, I would say 42.8 divided by 35.5, and then 9.6 divided by 16. So this comes out to be 0.6025, something around this. This is 1.205, and this is 0.6. So the best way is to divide it by the least, divide by least to form out, or normalize it just in a simple way. So this comes or divided by, this is zero point 0.6 approximately, this is divided by 0.6, and this is divided by 0.6. This comes out to be 1, this is approximately equal 1, and this approximately equals to 2. So the formula would be something like SeCl2O. You can write it like this, or SeOCl2. Any of these formulas you want to write, both are correct. So the empirical formula, SeCl2O or SeOCl2, any of them, any way you want to write. So this is the way you can solve this question. This is the way you can write the answer for this. So moving ahead, question 2, part E, it says a sample of oxygen has a volume of 11.5 decimeter cube at room temperature and pressure. The temperature, part 1, the temperature of the sample is decreased. With the pressure remains constant. So remember PV equals to nRT. So what we are doing, temperature, we're decreasing the temperature. Remember, this is almost constant, whereas pressure is kept constant. So pressure is kept constant, so the volume will change a bit. So it says describe and explain using kinetic what happens to the volume of the sample. So remember, the volume will, temperature decreases, pressure remains constant, so the volume will eventually decrease. So why see it this way. So if you're going, just try to do it in a mathematical manner. So V divided by T equals to NR divided by P. So this is, for example, you have this as constant. So V by T is a constant. So if one of your value is decreasing, that is temperature, in order to keep this constant, your volume will also decrease. So then it will remain constant. Or otherwise, say if your temperature decreases, volume increases, this constant will, or this overall value will decrease. So this is one way, but you have to describe using kinetic particle theory. So with kinetic particle theory, we can simply say that, or you can write the decrease in temperature uh, at constant pressure decreases the average kinetic energy of the molecules, the rate of collision between the molecules decreases, thereby decreasing the volume. Okay, just simply write something like that. And remember, you can write it on your own words. Make sure that it lies in these two lines. That will be a good option. So the key 2 points you have to keep in mind, that you are decreasing you're decreasing the temperature at constant pressure. So the average kinetic energy of the molecules will be decreasing. That will be decreasing the rate of collisions between the molecules, and overall the molecules will occupy less space. That eventually decrease the volume. Then part 2, it says pressure is the pressure of the sample is decreased, the temperature remains constant. So again, something like this, PV equals to nRT. So this part remains constant, so PV equals to constant. So you have to, so if we have to decrease the pressure and we have to keep PV as constant, so what happens to the volume? Again, describe and explain using kinetic particle theory what happens to the volume. So if pressure is decreased, we have to keep this product constant, so volume will increase. So remember, the volume of the sample will increase. So how? So at constant temperature, you can say the decrease in pressure at constant pressure at constant temperature results in molecules of the sample getting far away, uh, or far apart from each other. The rate of collisions, rate of collisions of molecules decreases, thereby increasing the volume. Okay, so this is how it goes. Again, you can write this whole statements in your own words as well, but make sure you keep these points in your answer. So moving ahead, question number E part, question 2 part E sub part 3, it says calculate the mass of oxygen in 11.5 decimeter cube sample at room temperature and pressure. Give your answer to two significant figures. So we have to basically calculate what, or let's see what's the data we are given. So mass of gas we have to calculate. We are given volume. So volume is 11.5 decimeter cube. Um, remember, so we have to use PV equals to nRT, and the value of R or the car is constant, that is 0.0821. That is generally used. The temperature value at room temperature, it means 273 plus 25 degrees, for example. So I take it 298 Kelvin as room temperature, and pressure at is 1 atm. So these are values, or these are the values which are given to us. Simply, we have to find out n. If we find out number of moles, and from here we can easily find out the mass of oxygen. So if for number of moles of oxygen, if we have to find, we can just simply say, or we have to just put in the values. So n equals to PV over RT. Pressure is again 1 atm multiplied by 11.5 decimeter cube divided by 0.0821 multiplied by temperature is 298 Kelvin. So it comes out to be 0.47 moles of oxygen, and molecular mass of O2, oxygen is 16 into 2, that is 32. Molecular mass of oxygen is 2. And remember, we have to give the answer to two significant figures. So mass is 32 multiplied by 0.47, and that comes out to be 15.04 grams approximately. And for two significant figures, it becomes 15 grams. Remember, one and two significant figures. This is important. So my answer will be 15 grams. Okay. Next question. Question number 3. It says there is concern about the disposal of plastics made from non-biodegradable polymers. Part A. The partial structure of non-biodegradable polymer is shown. First part of part A. Name the type of polymer shown. Okay. So this is a type of addition polymer that is shown over here. And we can see from here that these are the blocks that are repeated again and again. So we are technically adding one block to another. So that is just simply type of the polymer is addition polymer. Okay, this is an addition polymer we have. Then draw the structure of the monomer used to make this polymer. Okay, so the monomer will be so if we just simply see this polymers, it would look something like this is N, this is CEL, this is H, this is H, this is CH3. Something like this will be the polymer. And if we have to find out the monomer, we will have a double bond here, and these bonds will be here. So the monomer will look something like this. C double bonds, this comes with Cl, this comes with H, this comes with CH3, this comes with H. So the monomer that is used to make this polymer will look something like this. Okay, or the structure of the monomer will look something like this. So moving ahead, part 3, it says the polymer is often disposed by combustion. Uh, Suggest one problem associated with this method of disposal. So remember, the polymer we are saying it contains, it is containing. So this is, for example, this is the polymer we are talking about. Um, CH, CH3, this is chlorine, and this is hydrogen. So generally, when we burn any polymers uh, or hydrocarbons, carbon, hydrogen, or compounds related to carbon, hydrogen, oxygen are the byproduct. But we have now chlorine, and chlorine, if you burn any compound that contains chlorine, that is technically poisonous gas. So one of the disposal with combustion may result, or you may say will result in the release of any poisonous emission. So we can just simply write one problem. The emission of poisonous gases slash fumes because of chlorine is one of the problems as associated with the disposal of this polymer with the help of combustion. So moving ahead, part B, it says lactic acid is used to make polylactic acid, a biodegradable polymer. The structure of lactic acid is shown. So just what is meant by biodegradable? So biodegradable means that the substance is decomposed using by the natural decomposition mechanism or the natural bacteria, you can say. Uh, Biodegradable means it means that the substance can be decomposed using natural means, natural, or you can say, or bacterial means slash mechanism. Okay, anything or any thing that explains, or any words of yours that explain this statement will be considered as correct answer. So moving ahead, it says draw the partial structure of polylactic acid. Show at least 2 repeat units. Okay, so this is the, you can say, the lactic acid we have. So repeat units. So this is following a poly. So it would be something like OCH3H. This comes as C double bond O, and this is O. this is something that repeats again and again. Uh, and this is how we have to show. So at least two repeat units. So let's draw it. O C H CH3 C double bond O dash O, and then we have to repeat it again. So O dash C CH3 H COO dash O dash. So it goes here and it goes here. So two repeatable structures. So this is one, this is two. So the partial structure will look something like this. Uh, Then part three, it says a factory uses 500 tons of lactic acid to produce or to make polylactic acid. The percentage yield is 100%, but the mass of polylactic acid made is less than 500 tons. Explain why the mass of polylactic acid is made is less than 500 ton. So the only reason is that this process is what is happening here is condensation polymerization. So this is a condensation polymerization reaction. There will be some byproducts, and that is why you can say that the mass of polylactic acid will not be 500 tons, because there will those byproducts will weigh something. Um, so why the mass? You can say this is condensation polymerization reaction. Uh, there will be small, there will be, you can say, a small molecule as a by molecule formed as a byproduct of this reaction. Okay, so that is the only reason why you don't get complete 100% or the 500 tons of polylactic acid as a result of polymerization of this compound. So moving ahead, it says aqueous lactic acid react with potassium manganate. There is a color change from purple to colorless. So remember, then acid reacts with potassium manganate. What happens to the lactic acid in this reaction? So acid reacts with potassium permanganate, so it is oxidized. So um, so the lactic acid is oxidized. Okay. So next part says aqueous lactic acid is neutralized by aqueous sodium hydroxide. Write ionic equation. So remember, it is a neutralization reaction. So the acid provides you with H positive, hydroxide or bases provides with you with OH ions, and the byproduct is simply H2. So the ionic equation, you do not have to write the complete formulas for lactic acid and sodium hydroxide and water and the other byproducts. Just simply write the H positive plus OH negative gives you H2. This is the equation they need. Then part 6, it says aqueous lactic acid reacts with magnesium. So acid reacts with the metal. Name the gas that is produced in the reaction. So whenever a acid reacts with a reactive metal, hydrogen gas is produced. So name the gas. So just simply hydrogen gas. So it seems pretty simple at the moment. So this is how this question ends. So remember, most of this work or in such questions, uh, this is, you have to memorize quite a few of these things, and some of these reactions or some of these things, the more you solve past exams, the more you know practice, and the more you read, you will be able to answer these questions in a much better manner. So moving ahead, question number 4, it says zinc bromide and zinc carbonate are two ionic compounds. Okay. It says predict two physical properties other than electrical conductivity of zinc bromide. So it is ionic compounds. So ionic compound have high melting point, high boiling point. So they are soluble in water, insoluble in organic compounds, and things like this. So just simply zinc carbonates and zinc bromide, you can just simply say number one, high, sorry, melting point. You can also say high uh, boiling point. Uh, then you can also say soluble in water. In water, you can also say insoluble in organic solvents. So these are some of the properties of you can say these ionic compounds especially. So then question number 4 part B, it says zinc reacts with bromine to make zinc bromide. Okay, zinc 2 plus and bromine 2 negative ions. Explain in terms of movement of electrons how zinc bromide is formed from zinc atoms and bromine molecules. Okay, so just simply remember uh, um, zinc atom, it loses 2 electrons to form Zn2 positive ion. Bromine gains 2 electrons. Bromine gas gains 2 electrons to form 2 Br negative ions. So just simply uh, zinc atom loses 2 electrons to form Zn2 plus ions, and bromine gas, and that is Br2, uh, gains uh, 2 electrons. So 2 electrons to form 2 Br negative ions. Okay, and that is how this whole complete reaction goes. So 2 electrons lost, 2 electrons gained. Or you can also say that bromine gas Br2 gains 1 electron to form Br negative ions. But generally, in this sort of reaction, it's good to say that total number of electrons are lost and total number of electrons are gained remains the same. So you can always have 2 Br negative ions. So then question number 4, part C, it says aqueous zinc bromide reacts with magnesium as shown. Write down the equation, use the equation to help the oxidation takes place. So remember, oxidation is a loss of electrons. So oxidation is loss of electrons. So loss of electrons taking place where? So zinc is actually gaining 2 electrons and becoming zinc. So oxygen, it says zinc Zn2 positive ions loses 2 electrons to form sorry, my bad. So zinc is loss of electrons, that is right. So loss of electrons only. Oh, so magnesium is losing 2 electrons. So this is a mistake. Sorry, I'm really my bad. So magnesium Mg um, loses, yeah, or you can say magnesium atom loses 2 electrons to form Mg, 2 positive ions. Okay, so this is how oxidation goes. Equation to that reduction. So reduction is gain of electrons. So the reduction again gain of electrons. So again, if magnesium is atom is losing, so you can say zinc ions Zn 2 plus, um, gain uh, 2 electrons to form zinc atom, or to just simply form Zn plus. So this is how this goes. So next question next part number D, it says zinc carbonate is insoluble in water. So remember, uh, soluble carbonates generally very few carbonates are soluble. For example, sodium carbonate, potassium carbonate, aluminum carbonate. Rest all carbonates are insoluble. So zinc carbonate can be prepared by reacting zinc bromide with carbonate ions in a precipitation reaction. So name a soluble aqueous solution that can provide carbonate ions. So remember, any salt or any carbonate salt that is soluble in water, if we dissolve that in water, that will give us carbonate ions. So the soluble carbonate are sodium carbonate, potassium carbonate, and aluminum carbonate. So you can write either of them. So for example, sodium carbonate is soluble. You have potassium carbonate as soluble, carbonate as soluble. You have ammonium carbonate as soluble, ammonium carbonate. So these are only the soluble carbonate that are available to you, and whenever you have to find, or you need to have carbonate ions in an aqueous solution, just use any of these salts, add them to water, and you get those. Uh, then part D, part two of this question, it says a sample of zinc carbonate is heated strongly. So if you are basically heating a carbonate, name the products of this reaction. So one of the products will be carbon dioxide gas for sure. So, and the other will be an oxide. So zinc carbonate, ZnCO3. If you heat it, for example, it becomes zinc oxide plus CO2. CeCO2. Yes, that's the balance equation. So just simply name the products of this reaction. Uh, it will be zinc oxide and carbon dioxide. Okay, carbon dioxide gas. So moving ahead, the next question, question number 5, it says petroleum or crude oil provides the raw materials for making ethanol and ammonia. Okay, so it says part A, describe how petroleum crude oil is separated to make fractions as naphtha and petrol or gasoline. So remember, the crude oil is heated in a fractionated column. The oil heats up, and it evaporates, not evaporates, it vaporizes technically, and it vaporizes, becomes less dense, and moves up the fractionating column. And since it has multiple of its constituents, and every of these constituents is different as far as the mass of the constituent is concerned. So as it vaporizes, uh, if we are able to, or in the fractionating column, we select differentiate these vapors at certain heights, condense them and take them out, and that those are the in a way we can just simply you can say take the individual constituents out of this petroleum. And here what we are seeing naphtha and petrol. Naphtha is much heavier compared to gasoline, so we just simply heat them, and based on the difference in their boiling points, we can just simply separate them in a fractionating column. So that this is the whole overall process we have to describe. So let's try to write it. Uh, so the crude oil is heated in a fractionating column. the oil vaporizes and moves up the column at different rates. These rates are based on the different boiling points of the constituents of the oil. Okay, these constituents are then separated by condensation at different heights across the fractionating column. Okay, so this is how you write it. Then part B, it says compounds such as C11H12 in the naphtha fraction are cracked to make hydrogen alkenes and smaller alkanes. So it says explain how molecular formula of C11H12 shows a compound is an alkane. So remember the general formula of alkane, the general formula for alkane is CnH2n plus 2. So for here, so for n equals to 11, we have 2n plus 2 equals to 24. Thus, the compound is an alkane. Then question part 2, B part 2, it says construction equation show how the cracking of C11H24 to make ethene and alkane only. So CH, so one of the byproducts is ethene, 11H24. So we are heating it. So heat. One of the byproducts is ethene. So ethene is C2H4. And an alkane. So remember the other alkane is going to 4 is minus C20H9. So consider 2n plus 2. Yes, this is an alkane. This is an alkene. So this is how this equation can be written as. Next question, question 5 part C. It says describe how hydrogen is converted into ammonia in the Haber process. Include conditions used in the Haber process. Okay. So a few things to remember. Just first try to write. So Haber process is nitrogen plus hydrogen. It's a reversible reaction that forms ammonia in the presence of a catalyst that is iron. The temperature range is somewhere 400 to 500 degrees C. The atmosphere or the pressure is somewhere around 200 atm to 400 atm. So this is the overall equation we remember. Okay, and all the things we have written here, we have to write it out. Remember, this is a 3-point equation, so we have to make sure we write 3 of these conditions properly. So in words, let's write the hydrogen gas. Remember, this is gas is made to react with nitrogen gas at high temperatures and write in brackets 400 to 500 degrees C. Uh, at high temperatures and high pressures. Again, in pressure, write 200 to 400 atm in the presence of iron, iron Fe catalyst. Okay, so this is a good answer. So you have mentioned all the three conditions, and this is a 3-point question. So we are good with such an answer. Next part, say state one other use of hydrogen gas. Hydrogen gas is used in fuel cells, and also hydrogenation making of margarine, fuel cell. So we can say fuel, fuel cells. Using fuel cells, it's also used in fuel. It's also used in making margarine. Okay. Then part E, ethene reacts with a compound to make ethanol. So remember, C2H4 reacts with something, and that gives you CH2H5H. Okay. And what would be that compound? So remember, one is extra component that is coming is O, the other is 2H. So this will be some H2O if we do this. So the compound is water or steam, high temperature. State one condition for this reaction. Again, this water must be heated or high temperature or steam. Uh, high temperature. Okay. And in presence of catalyst. Presence of catalyst. So one condition, high temperature is good for that, or in the presence of a catalyst. Okay, so this is how the section A of this paper looks like. So now moving to section number B, and remember in section number B we are generally given with 4 questions, and out of these 4 questions we have to attempt 3. Uh, but again, in this work I'll be solving all the 4 questions for you. So again, I would say a good way to go about this way, solving this section is first, at least with a calm mind, read all these 6 questions and see which of these questions you are able to answer properly. These questions will have some serious theory part, and always try to attempt questions which do not involve writing more of the stuff, just like the ones which involve writing simple equations, solving some mathematical problems, because those questions will eventually or will have a greater probability and chance of getting you good grades or good numbers. Okay, so moving ahead, let's start. It says question 6, it says sulfur dioxide and oxides of nitrogen are pollutants in air. Part A, state one environmental problem caused by presence of sulfur dioxide in air. So it causes acid rain. It's simple. It causes acid rain. This is a key problem of sulfur or sulfur pollutants in air. Part B, coal-fired power stations produce sulfur dioxide as pollutant. The sulfur dioxide is prevented from entering the air by a process called flue gas desulfurization or FDG. Name a compound used in flue gas flue gas desulfurization that reacts with sulfur dioxide. Sulfur dioxide generally react with carbonates, or in a way in this reaction, the calcium carbonate is the compound that is used in desulfurization. Moving ahead, next part C, it says coal-fired power stations also produce oxides of nitrogen such as NO. NO is produced when nitrogen reacts with oxygen. Construct an equation for this reaction. So nitrogen plus oxygen, my byproduct is NO. So now I have to balance. So I have two nitrogens and two oxygens. So just have like this. Now this my equation is balanced. It's as simple as that. So then part 2, it says draw a dot and cross diagram to show the bonding of molecule of nitrogen. Okay, so remember this is N2, molecule of nitrogen. Okay, only include outer shell electrons. Okay, so for nitrogen, um, molecule of N2. Okay, so say for example, this is my first cell of nitrogen, and this is my second nitrogen molecule N. So I can use the cross for this, and dot for this. So number 2 shells for this, and the remaining, uh, uh, because nitrogen have 5 outer shell electrons. Okay, so 5 here and 5 there, so it means that we have total of 10 electrons. So we have to balance these 10. So 2 will remain with each, and the remaining 8 will be shared. Right? Something like 2 to 4. The remaining 6 will be shared. And that will eventually make a set of 8. 2 electrons. Electrons will be in pairs. So this one electron, this one electron, and this one electron. So we have 1 pair, we have 2 pair, we have 3, 1, 2, 4, 6, 8. At the moment, 8 are in this shell, and 6, 8 of this. So this is how it will look like. So the key thing over here is that you have to balance the total of 10 electrons in such a manner that at a time in one shell there will be no more than 8 electrons. So the 2 nitrogen electrons will stay here in this shell. On this side, they will not participate in the bonding, or at the moment, whenever the nitrogen molecule is bonded, 3 of the electrons from the nitrogen cell will be taking part, or will be, you can say, the ones responsible for pairing up with the 3 other nitrogen electrons, so such that in an outer shell, the number of shells, or the number of electrons, will not be more than 8 at a time. So moving ahead, next part says explain the rate of reaction. Explain why the rate of reaction between nitrogen and oxygen increases as the temperature increases. So remember, as the temperature increases, the molecules, or the average kinetic energy of the molecules, will increase. That increases the collisions between the nitrogen and oxygen molecules, thereby increasing the rate of reaction. That is what we have to write. So just simply the increase in temperature increases the average kinetic energy of the molecules of O2 and 2. This increases the rate of reaction, this increase the rate of collision between and nitrogen and oxygen, thereby increasing the rate of reaction. Okay. So next, moving ahead, part D, it says nitrogen dioxide reacts with water to form mixture of dilute nitric acid, HNO3, and dilute nitrous acid, HNO2. Then an equation is given. It says 2NO2 plus 2 plus H2O is equal to HNO2 plus HNO3. It says the nitrogen part 1. It says nitrogen dioxide reacts with aqueous sodium hydroxide. Okay, nitrogen dioxide reacts with sodium hydroxide to form two different salts and water. Construct this equation. So nitrogen dioxide N2O react with aqueous sodium hydroxide NaOH to give two different salts and water. So one is water, H2O. Then we have two different salts. So one of the salt will be N. So remember, this is the nitrogen oxide that is reacting with water, HNO3 and HNO2. So from here we can see that if we remove H from here and if we so that this will be taken up by the or goes to water and the salt comes here. So the sodium NaNO2 plus NaNO3. So now let's try to balance it. So sodium is 1. We have 2 sodium here. So what if we add 2 here? So we have 1 nitrogen. We have 2 nitrogen here. So we have 2 nitrogen here. We have 3 and 2 5 and 1 6 oxygen, 2 4 and 2 6 oxygen. We have 2 hydrogen, 2 hydrogen. Okay, so this equation will be 2 2 and this. So this is how you can write this equation. Easy guess is always remember that the in the exam the questions are interrelated. There is no equation or nothing that is written that do not have a meaning in this question. So if this equation is written, it does contain some meaning in this part. So the aqueous sodium hydroxide just replace the hydrogen in these in the upper equation, and you will be able to find out what would be the two salts are. So moving ahead, it says nitric acid is strong acid, nitrous acid is weak acid. Describe the difference between weak acid and strong acid. So the difference is that the strong acid completely disassociates when added to water, whereas a weak acid partially disassociates in an aqueous solution. So uh, the strong acid completely disassociates, or you can say ionizes, when added aqueous solution, or you can say water. Whereas weak acids partially disassociate or ionizes when added to aqueous solutions or water. So this is how it goes. So moving ahead to the next question, question number 7. It says sulfamic acid NH2SO3H is a white crystalline solid. It reacts with aqueous sodium nitrite to make nitrogen gas as shown in equation. Okay, so this is the equation that is given. The excess of sulfamic acid reacts with 20 centimeter cube sample of 0.15 mole per decimeter cube of sodium nitrite. So it says calculate the maximum volume in dmq decimeter cube of nitrogen formed measured at room temperature and pressure. Okay, so this is a simple titration problem. And with this titration problem, we can find out the moles of sodium nitrite. And from that, if we have the number of moles, we can easily find out the total volume. Uh, so first of all, so it has two questions. So again, remember what is the sulfamic acid is in excess. So this acid is in excess, and this is the limiting quantity. So we need to find out the moles, and this limiting reactant will be determining the amount of volume or the volume of nitrogen that is formed. So from this reaction, we can see one thing. We can see that number of moles, 1 mole of nitric acid results in 1 mole of nitrogen. Sodium nitrite results in 1 mole of nitrogen gas that is produced. So excess sulfur. So number of moles of, first of all, calculate number of moles of NaNO2. If we can calculate this, let's see. Try. So we have volume of NaNO2. That volume is 20 centimeter cube. And then we have a concentration of NaNO2, and that concentration is 0.15 mole per dm cube. Okay. And remember, 1 dm cube is 1000 centimeter cube. So from here, we can find out number of moles. So number of moles of NaNO2, this will be equal to 20 centimeter cube multiplied by 0.15 mole per 1000 centimeter cube. So this will give me 3 into 10 to power minus 3 moles. This is the number of moles of sodium nitrite we have. So from the equation, we have 1 mole of NaNO2 gives 1 mole of N2 gas. So if we have 3.3 into 10 to the power minus 3 moles of Na2, we will have 3 into 10 to the power minus 3 moles of N2. As simple. So now we have number of moles of nitrogen gas. So remember why we are using sodium nitrite, because this is the limiting reactant, because it has already told us that the sulfamic acid is in excess. Okay, so with this limiting reactant, PV equal, now use the PV equals to nRT, the formula. And remember, we have solved one of the questions earlier in this exam as well. And this is a very important thing to remember, because there are always questions coming with this that involves usage of this formula in the exams for previous quite some time. So it's always good to practice questions that involve using of this formula and calculation with respect to moles or titration something. So here we have to basically calculate the value of V. So from this we can say that the temperature, I can assume room temperature is 273 plus 25, 298 kelvins. R value is 0.0821. That is, again, remember, atm dot dm cube per mole. That these are the units. Pressure is 1 atm. You have to calculate the volume, and number of moles is 3 into 10 to the power minus 3. So we have N, we have R, we have T, we have P, and we have to calculate value of V. Oh, so we have to calculate value of V. V equals to nRT divided by P. So just simply multiplying 3 into 10 to the power minus 3 multiply by 0.0821 and multiply it by 298. So this comes up to be 0.0733974 decimeter cube. So this is the volume. So it says calculate volume in decimeter cube of nitrogen formed at the room temperature. So generally, it's good practice to three significant figures. So 0.0734 decimeter cube. This will be a good volume or good answer. So this is how you solve this question. So next part B, it says the rate of reaction can be determined by measuring the volume of nitrogen formed every second. Draw a label diagram of the assembled apparatus that can be used to make and collect the measure the volume of nitrogen in this reaction. So again, we are basically reacting acid and a base. So we have you can take a flask, and in this flask you can have the limiting is sodium nitrate. So this is your NaNO2. You have the excess solution. This is your excess of NH3SO3 ammonium sulfamic acid, and then you have you can say a glass tube that goes to a syringe. You can draw it something like this, and this is how a syringe will look like. And there will be some sort of fixture that is preventing any leak. So this is you can measure this is volume of nitrogen gas. This is your flask. So remember, are we heating the experiment? No, so we do not need a burner. So that is fine. So this is you can say a rubber stopper to avoid leakage of gas. So this is your glass tube. Glass tube, or you can also use you can say a glass tube is generally better than a rubber tube, because sometimes there are chances of any reactant reacting with the rubber. So glass tubes are pretty inert for most of the gases. So again, this is again glass syringe or a glass pump to correct sodium. Actually, you can also write it as an aqueous access. So this is how a label diagram for all this will look like. So this is you have to make sure that this is sodium nitrate, looks like a salt, and that is having much little compared to excess of the sulfamic acid. So that shows that we have less amount of sodium nitrite with us, and that is the limiting reactant in this case. So this is how we draw a label diagram. Make sure you can say label all the operators properly, and yeah, that is I think pretty good for this case. So moving ahead, part C says that the concentration of NaNO2 sodium nitrite is increased. So now you have increased the concentration. The temperature of the reaction remains constant. State and explain how the rate of reaction changes. So if we see PV equals to nRT, so temperature remains same. Concentration is increased, so you have more number of moles. So what will happen? So the rate of reaction, and we have excess amount of you can say acid that is available. So we have more concentration, so the initial rate of reaction will be much faster. So how we are going to explain it? Let's say there will be more number of molecules of NaNO2 per unit volume. This increases the probability of collision of these molecules with excess acid, thus increases thus or increasing the overall rate of reaction. So overall rate of reaction will be increasing in this case. So moving ahead, part D, it says sulfamic acid forms salts called sulfamates that contains the anion NH2SO3. Magnesium carbonate, then again insoluble carbonate, magnesium carbonate is added to the sample. Magnesium sulfamate, water and gas are formed. The gas turns lime water milky. Write the equation for this reaction. So the lime water milky is caused by CO2 gas. So remember lime water milky, that is a test for a CO2 gas. So magnesium carbonate, again MgCO3 plus sulfamic acid NH2SO3H, and that two reacts and to form we have water. So we have one of the thing is water plus carbon dioxide plus a sulfamate salt. So sulfamate salt, again magnesium sulfamate, so magnesium NH2SO3 whole twice. So this is magnesium sulfamate. So now let's balance this equation. So CO2, so we have one carbon, so we have two of these sulfamates, so multiplied by 2. So let's see now, is it balanced? So 2NH2, so this is 3, 2H, so 2H, 2 oxygen, 3 oxygen, 3 oxygen, 1 magnesium, 1 magnesium. Okay, yes. So now this equation is balanced now. So we are good. So now we have not only so for this equation, remember you have to make sure that number one, this is balanced. Number two, the salts are written correctly. Number three, you have identified carbon dioxide gases correctly. So if these three things you have done correctly, you'll get complete points for this question. Okay. So moving ahead, next question, question number 8. It says lead is a metal with proton number 82. Number it's a part A. It says use periodic table to state the number of occupied electron shells in an atom of lead. So lead is 82. So remember, first shell will have 2, second shell will have 8, third shell will have 18, fourth shell will have 34, and so on. So if we calculate 2, 8, 10, 28, and 34, this comes out to be 62, and we are total of 82. So the remaining electrons will be 20. So 20 remaining. So now we have to place 20 into in number of shells, and remember the placement would be such that least number of shells will be required. So 20, so we can have either 34, so we can't have 18, yes, so 5/5 shell will have 18, then remaining will be 2, so 6 shell will have 2. So there will no need of 7 shells. So the maximum number of shells will have, so we have 6 shells. Okay, so number of occupied electrons, number of occupied electron shells in an atom of lead is 6 shells. So use periodic table to state the number of electrons in the outer shell of atom of lead. So the outermost shell is 6 shell, 2 electrons. will be in the outermost shell. Not exactly two, I would say. It would be 4 electrons. Hmm, okay, yes, there will be 4 electrons. Okay, so instead of following this will give you the number of shells, but uh, the best way is to first shell will have 1s2, the second shell will have 2s2, uh, 2p6, third shell will have 3s2, 3p6, and 3d10, so total of 18. Fourth shell will have 4s2, 4p6, 4d10, and 4f16. Yes, then fifth shell will have 5s2, 4 or 5 p6, 5p10, and so on. Sixth shell will have 6s2, 6p6, 6p10, and so on. So the how the electrons, the first shell will have two, the second will have so first we'll have two, then we'll have two, then we have 2, 3, and 6, 8. So we have 2, 2, 8. Then we have 2 to 8 again, 6 and 2, 8. 10, 6 and 2, 10, 6 and 2. So 10, 6 and 2, 18. And then we have 10, 6 and again 2. Okay, so it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s2. Okay, then we have 3d10, 4p6, 5s2. Then we have 4d10, 5p6, and 6s2. Okay, so if we keep on adding these, we can simply say that the sixth shell will have 2 electrons here, and so 1, 2, 1, 2, 3, 8, 3, 2, 8, 8, 18. So 1, 2, 3, 4. Then 5s2, 4d10, 5p6, 5. So we have 1, 2, 3, 4, 5, and 6. 6 electrons. Yes. So a total of 6 shells. So there will be uh, so outermost will have a total of 4 electrons. So 4 electrons. Out of those 4 electrons, there will be 2 in s orbital, and there will be 2 in p orbital. Okay, so these will be the number of electrons that will be remaining. 6s2 plus and after that we have yes, we have p coming. Yes, okay. Plus the next p orbital we have get 2. So if we add them, this will be 82. So yes, so this is how you get 4 electrons. So first shell, second shell, third shell, fourth shell, fifth shell, and sixth will be this 2 plus these 2 elements. So technically this comes from molecular orbital theory, but if we see from the periodic table, uh, lead Pb82 is in fourth column. Just simply we can also write fourth column, and fourth column will have 4 electrons in the outermost shell. But if you are going to make a diagram like this, you will say that it will have 2 electrons in the outermost shell, and that will contradict your case or the way we are told to add the atoms. This basically comes from the molecular orbital theory. Generally, this theory is not covered in O-levels examination, but it's a good way to check that whether you have uh, done this thing correctly or not. But from the periodic table, just easy solution. Uh, 4 columns, and fourth column, the outer shell will have 4 number of electrons. Okay, so I beg your pardon that I take it to a different dimension, but anyways, so moving ahead, question number 8, part B, it says describe the with the aid of diagram the metallic bonding in lead. So metallic bonding, so remember there will be cations and anions, positive, there is sea of positive charges, or sea of electrons, I would say, not sea of electrons, positive, uh, the lead, the lattice, you can say the metal lattice will have, it will be much close by, not, it's good to draw it in a much closely and tightly packed fashion. Positive 3, 4, 1, 2, 3, and so on. And you can have these electrons like this: 1, 2, 3, 4, 5, 6, 7. So 7, it's good to have these 7. 1, 2, 3, 4, 5, 6, and 1, 7. So this is your electron, and positive, you can say it is as your cations, or we can also call it delocalized electrons. Okay. So describe the metallic bonding. So remember the metallic bond is a chemical bond, sorry, not bonds, formed by the electrostatic, uh, force of action between the closely packed, positively charged atoms, and we call it as cations, and the delocalized free electrons, delocalized free electrons, or anions, moving across the lattice structure of the cations. Okay, so this is what you have to write, and I would also recommend that this again question about metallic bonding is quite frequently asked. So you remember, you try to write a good answer for that and remember it. I would just write it as learn by heart, or you can just you know remember it, how the metallic bonding. Write 2-3 lines, and the key things you have to remember: the cations, sea of electrons, or the positively charged cations forming the core of the lattice, and and the delocalized free electrons moving around, can easily roam around that lattice, and there is a strong electrostatic force of attraction. These are the 3 points you have to mention to get the complete credit for this answer, and I highly recommend that you remember this thing, and this is frequently asked in the exams. So moving ahead, it says two physical properties of lead that are characteristics of all metals. All metals are malleable, ductile, good conductor of electricity, good thermal conductors. All metals are shiny. So there are many multiple properties. So you just simply cite malleable, ductile. Other properties, three, you can say good electrical conductors. Four, you can say thermal conductors. Five, you can say shiny. Metals do have a shine. So it's good. Then it says lead ethanoate is a crystalline soluble salt. Okay. Name a suitable combination of an acid and an insoluble base that is used to prepare lead ethanoate. Okay. So acid, again, lead ethanoate, so you can say ethanic acid. Ethanic acid will be a good choice. And insoluble base, all lead based bases. So ethanic base is there. Acid, so ethanoate comes from here. So base, you can say lead hydroxide. This will be a insoluble base. So this is a simple crystalline soluble salt. So the salt will be lead ethanoate, and the other part is water. So this is how you can easily uh, make the salt. So next part, it says aqueous lead ethanoate reacts with sodium iodide. It says a yellow precipitate of lead iodide PbI2 is formed. Construct an ionic equation. So lead ethanoate. So output is PbI2, and sodium iodide. So iodine is coming from here, and lead is coming from here. Okay. So aqueous lead ethanoate. So lead 2 positive, iodine like 1 negative. So balance it out to, so you have 2 iodine here, so 2 here, and this is aqueous. Again, this is aqueous solution, and this is salt. You can solid or SALT salt, or you can call it as S, and it is in the solid state. So this is how the equation goes. So again, we have to with symbols of this reaction. So state symbols, these are your state symbols. So this is in aqueous, these are your state symbols. So you can simply write the equation, you will get half the point. If you do not write the static symbols, you will not get complete points. Then part F, sorry, explain why solid lead iodide cannot be electrolyzed. Um, cannot be electrolyzed solid lead iodide. So solid lead iodide is a salt, and that does not contain free electrons or mobile ions, which are required for electrolysis. So you can say that the solid lead to iodide does not contain any free electrons or mobile ions which are required for electrolysis. Okay, so this is how we can just simply write this answer. So moving ahead, next question, or the you can say the last question for this exam, question number 9. It says the structure of, or it gives us the structure of ethyl propanoate, and it's shown. And it says that circle the atoms in the structure that show ethyl propanoate is an ester. Okay, so the ester can be found out by finding out this structure. So if we have something like this in a hydrocarbon or in an HCU, hydrogen carbon oxygen sort of compounds, this means that this is an ester. So part A will be this. Then question B, it says aqueous bromine is shaken with ethyl propanoate. Again, it's an ester with ethyl bromine. Explain in terms of structure of ethyl propanoate why aqueous bromine turns colorless. So remember, this carbon-carbon double bond is there, and aqueous bromine reacts with carbon-carbon double bonds, and eventually it, you can say, turns colorless because it, forms, you can say. So the structure of bromine reacts with the carbon double bond, and that is what is it is responsible for making bromine go colorless. Okay, part C, it says ethyl propanoate is prepared by reversible reaction between a carboxylic acid and an alcohol, and that is shown here. So this is an acid, this is alcohol. So this is an ester, and this is water. So this is what's happening. So it's an esterification reaction. So it says a mixture of carboxylic acid and alcohol is allowed to reach equilibrium. So name the alcohol used in this reaction. So alcohol is COOH. So it is ethanol. Ethanol. The formula is C2H5OH. Okay. So this is ethanol. It says the reaction uses an acid catalyst. State the effect of catalyst on the position of equilibrium. So if your reaction has reached the equilibrium, the catalyst will not have any effect on the equilibrium. Catalyst is basically used to reach the equilibrium much faster. So no effect of catalyst at equilibrium. Okay, there will be no effect on the equilibrium. Then part 3, it says the concentration of alcohol is increased. So you have increased this concentration. Describe and explain what happens to the position of equilibrium. So if alcohol concentration is increased, so technically the number of moles, so mixture is allowed to reach equilibrium. So okay, so alcohol concentration increased, so your forward reaction will increase. So reaction will start increasing. This describe and explain why this thing is produced. So you can say forward reaction, towards right increases, or uh, forward reaction towards right uses more ester and water is produced. The extra concentration of alcohol is used up till the new equilibrium is reached. Okay, so this is how, or this is what it is required from you, and just 2 points. So next part, part D, it says in an experiment, 10.8 grams of carboxylic acid reacts with excess alcohol. Okay, so alcohol is in excess. So the experimental yield of ethyl propanate is 9.45 grams. Relative formula mass of carboxylic acid is 72. Show the maximum possible yield of ethyl propanoate is 15 grams. Okay, so just find out the moles of the acid first. So calculate moles of, let me call it carboxylic acid as A. So moles of A is equal to, so we have 10.8 grams divided by molecular mass. So this comes out to be 0.15 moles. Okay. So from this reaction, 1 mole of acid gives us 1 mole of ester. So we can say 1 mole of A gives 1 mole of, let me call it ethyl propanate B of B. Okay, so 0.15 mole of acid will give 0.15 mole of B. And molecular mass of ester. And so let's find the molecular mass of ester. Oh, sorry. So the molecular mass of this is ester is C. So 1, 2, 3, 4, 5. So there are 5C. We have 1, 2, 3, 4, 5, 6, 7, 8. H8, and we have 1, 2 O's, O2. So C5H8O2. So molecular mass of ester. So we are looking at C5H8O2. So it will be 5 into 12 plus 8 into 1 plus 2 into 16. So if we add up all these together, the molecular mass will come out to be uh, how much? 100 plus 8 plus, yes, 100. So this is 100. So we can, so mass of of ester produced is 0.5 moles multiplied by mR of ester, that is 100, and that will give me 15 grams. So we have shown that 10.8 grams of A produces 15 grams of B. So this is actually shown. This is what we have to show. Okay. Then it says calculate percentage yield of ethyl propanate in this experiment. So percentage yield, percentage uh, yield. So amount of calcium propanate produced is 9.45 grams. Theoretical value is 15 grams and multiply by 100. So this comes out to be 9.45 divided by 15. 63%, not approximately. This is completely 63%. So percentage yield is 63. So that is how we calculate it. So that's all, folks, for this paper. For all of you who has listened and who have went through with this whole session, I thank you all, and I wish you all the best for your exams and future endeavors, and all the success to you. And thank you very much for listening. Take care. Bye bye.